So this is my first time doing this. Can I be starting soon?
Yes, I just wanted to quickly introduce us and you. I'm Denise. My husband Alvaro is the artist. We've lived here over 20 years and have been building little by little. And we're always happy to welcome the community and have community groups here. We're really honored to have Carl here today talking about something completely different. And I'm looking forward to it.
Okay.
Thank you.
Great. Okay, so I just want to say before I begin that if any of you have any questions during this discussion, please just feel free to jump in, okay? If you haven't understood something, it's really more kind of that I haven't explained it, and if you don't understand, I'm sure there are a bunch of people that have missed it too. Maybe it's a faulty explanation. So if you have a question about anything, just jump right on in there. So let's see, basically, as I was telling people who came in first, I'd actually written this book in 2017, but since then, the James Webb Space Telescope has launched, and now, rather than, they can actually see almost the beginning of time, so there's a lot more information out there than there used to be. So based upon new information, I've kind of revised my theory a little bit more fine-tuned it. But so we're going to kind of go through that and talk about it that way. And so I just first want to give you an idea when everybody looks up there into the sky, basically out there are trillions of separate galaxies. And that's the one thing, is that they're all isolated and separate with a lot of empty space in between them. When astronomers look out into space, I would say there's probably about 1 billion times more empty space than there is actually space with something in it. So there's just a lot of distance between galaxies, and galaxies are isolated. So it kind of leads us to the question, I guess has maybe been the age-old question: how did everything come into existence, and how did it happen? And the thing is that because of that, the Big Bang Theory, as you may be familiar with, starts with the idea that there's a giant explosion, and then everything kind of formed together and kind of clumped together from this giant gas cloud. That didn't really make a lot of sense to me, because I always thought, well, if there was a giant gas cloud, why is all the space between galaxies all empty? And so it didn't really make a lot of sense to me. So when I started thinking about it, and at the end of the show, or the end of the presentation, I'll actually tell you how I really came up with my theory. But I realized that maybe the source of the matter was actually inside of the galaxies. And that's really the crux of this theory, is that rather than a giant explosion and then galaxies accumulating from a giant gas cloud, instead, what I believe is happening is that galaxies are forming and actually continuing to form from the inside out, from what were central white holes. And so with that in mind, people then ask me, well, what is a white hole? Well, when you think about a white hole, really, it's pretty much the opposite of a black hole. Everybody has the picture of what a black hole is. Basically, things in, it's kind of compacting all the matter as tightly as it can and pulling everything in. A white hole is pretty much the exact opposite. Basically, a white hole is extremely thin, probably only the thickness of a single atom. And so when it makes something, the problem is it has nowhere to put it. So it has to push it out. And so that's why white holes actually make matter and push them out. They make it, but they have no place to store it because they're too thin. Okay? So that's basically kind of the overall of the theory. But let me kind of go through and explain to you how all these things form and how they all happen. So basically, what we see is when they look out there at these galaxies, and as I say, there are trillions of them. And quite frankly, we aren't even sure if we can even see the end of the universe. Maybe there are even quadrillions and just infinite number of galaxies. But the thing is that there are only 3 regular shapes. And that would seem pretty odd out of trillions of the thing that there are only 3 shapes. And let me explain to you what those 3 shapes are. There's, first of all, a spiral galaxy. That's the kind of galaxy that you normally think of. When you look at pictures of our Milky Way, and our Milky Way is a spiral galaxy, and so are a couple of close ones near us, especially the Andromeda galaxy, which we'll talk about later. But the thing is that they kind of swirl and they're flat, okay? And the thing is, if you look at them, they have 2 spiral arms, and that's why they're called spirals, because those spiral arms twist around their center. Now, the other thing with those galaxies is that they also have a lot of fresh, loose gas and dust, and so they continue to make new stars. And when you look at stars kind of work their way through what they call generations. And initially, when there's almost all hydrogen, they're very blue stars. They're bright blue stars, they have pure fusion. As they get along a little further, they become the second generation star will be yellow. That's like our sun. There are other contaminants in there, so it's not pure fusion. That's why we don't have a blue star. We have a yellow star. And then a third generation star is these red stars. They have so much other kind of junk in them that they don't really, they don't have that pure fusion. They're a lot less strong, they're a lot less bright, and they have a lot less energy. So the thing is, so that's what spiral galaxies are that you're normally used to seeing. And we're going to talk about galaxies a little bit more, but I just want to give you a little overview. The second type of galaxy is what they call a lenticular galaxy. That is also flat like a spiral, but it's a messy galaxy. It doesn't have that nice pattern to it. They also tend to have more yellow and red stars than a spiral galaxy would. And then the last type of galaxy is what they call an elliptical galaxy, but really it's a ball-shaped galaxy. And if you want to talk about a complete mess, that's what that is. Stars are going in every different direction. There's not the slightest bit of pattern to it. And so we have to wonder, how did these three types of galaxies form? And my theory is simply, and that is that there are white holes in the middle of these galaxies forming the galaxies. And the way that you determine which type of galaxy comes out, it's a matter of how many white holes form the galaxy. And one white hole will form a spiral galaxy, 2 white holes will form a lenticular galaxy, 3 white holes will form the chaotic ball-shaped elliptical galaxy. So does everybody kind of following me so far? I'm not having eyes glazing over or anything like that. Okay, great. So let's see. So with that in mind, when we look at spiral galaxies, we see these 2 arms that come off and they're spinning away from the center. But what you always notice when you look at them is that the arms always start on opposite sides of the center. Now, a lot of these spiral galaxies will have what they call bars, and we'll talk about how they come to be in a little while. But the point is they come off of opposite ends. Okay. So the idea though is with the I'll now probably show you how they actually form. So as I said, a spiral galaxy will form around one white hole. Now, as you see, when it's pushing its hydrogen gas out, it's pushing it out in straight lines. It's not disturbed. This will eventually grow and become a really straight line, and eventually those lines will twist, and we'll go through that a little bit more later. But that's one white hole. The flow of the hydrogen is very fast, and it just pushes out with no disturbance, no turbulence, and it pushes out in a straight line. Now, if you had 2 white holes together, they're not going to push out straight. What happens instead is this gas is flying off to the side straight, but the ones that's coming into the middle, this is clashing, and it's causing a lot of turbulence and confusion. And that is why when you have 2 white holes together, they form this type of galaxy, a lenticular galaxy. You see, it's flat, but it's messy. It doesn't have the nice patterns of a spiral galaxy that you can see an arrangement in. Okay, the flow is confused, and that's why it's messy. But 2 of them still are on the same plane, and so they're still flat. Now, when you have 3 or more white holes together, now they're pointing in all different directions. Okay, and when they're pointing in all different directions, this hydrogen flow is a mess. It's very confused. It's going a mess in multiple directions. And that's why this very disturbed flow causes in multiple directions and causes this chaotic ball. Okay? When you look at elliptical galaxies, they tend to have older generation stars because all their stuff is packed really tightly near the center. Whereas spiral galaxies, they kind of spread out a lot more. Okay? So we kind of go on here from that. What we also find is that these elliptical galaxies, they tend to, especially the larger ones, they all tend to line up in what they call great walls. When they see them, they look at them, and they're like a sheet of paper. They'll find these different walls. They have one which is called the HCB wall. Okay, and this galactic wall is 16 billion light years long, 10 billion light years tall, but only 1 million light years thick. Basically, it's the same dimensions as a sheet of paper. Well, you wonder, how in the world can you have something out there that looks like a sheet of paper out in the universe? And, well, the idea of the white hole theory is that white holes are really originally were part of a second dimension, and the second dimension became the third dimension when it shattered. And so the thing is, these galaxies, these massive, messy galaxies, because they grew so quickly, they had a lot of mass, so they didn't move very far. And that's why they're still in a line, because that's the line they started in. They just never changed their position. Whereas other galaxies, we'll see the spiral galaxies, they move a lot. Some of them, our Milky Way is moving at an estimated 1/4 of the speed of light. So we're really moving across the universe really quickly. And so, we'll talk about that a little bit more. But so the idea, though, is that they find these massive elliptical galaxies, and probably most of the universe's matter is trapped in these flat planes, or these flat sheets that almost look like sheets of paper, which seems really unusual. But that's how I believe they formed. Now, astronomers and Big Bang Theory, they can't come up with any rationale for this, and that's one of the reasons why I believe my theory, my hypothesis is correct as opposed to theory. And I should also point out why I call this a hypothesis rather than a theory. A theory has more been established by, they've got a lot of science behind it, it's been tested, and they then show it to be proven. This is a hypothesis because this has not really been tested by anybody. Now, I actually sent my book, when I originally wrote it, to about 300 or 400 of the top cosmologists or people who study the origins of the universe. When I first wrote it, didn't hear a word. It was like crickets chirping. I didn't get a single response from any of them. I sent them emails, no response. I would call them on the phone. Only one of them actually picked up the phone, and once he picked up the phone and realized what I was talking about, he quickly made a reason to come up to talk to me later and never call me back. So the point is that I think it's really because I have the wrong letters behind my name. As a lot of you know, I'm an attorney rather than a trained astrophysicist. But I always point out to these people who are skeptical of me. They say, "Well, you're just an attorney. What do you know about astrophysics?" And I'm like, "Well, I know another attorney who was an astrophysicist, and that's Edwin Hubble. He was a retired attorney, so I feel like I'm in good company there because basically he's the guy that figured out that there were galaxies. He also figured that everything was moving apart from us really fast, and he also figured out how to measure the speeds of galaxies, which he calls the redshift. But we won't get into his theories today, but the point is that I don't feel unqualified by being an attorney just because I don't have the astrophysicist education. I will say, though, that I think that maybe one of the differences and one of the reasons why an attorney does actually make a good astrophysicist is because we actually follow the laws and we realize that you can't break them and we don't make crazy assumptions. And as you'll see with the Big Bang Theory, they do, in my opinion, make some rather crazy assumptions like dark matter and dark energy. If you talk to them, they would tell you that 95% of the universe is dark energy, but you can't even see it. And another, but maybe that's not quite the right amount, but maybe 70% is dark energy, and they'll say 20% is dark matter. But the point is that it seems crazy that they try to say that what you can't see is real, whereas I think that we should follow the observations, which I think of as facts and scientific law, and I think that's how you reach the correct conclusion. And hopefully that's what I've done, and hopefully that's where my theory is. But so now we're not going to talk about what we call high speed or high velocity massive galaxies. And the thing is, when we talk about these, we look at, is everybody following so far? Am I talking too fast? It's all good? Okay. So the thing is that when we look at these high mass, high speed galaxies like our Milky Way has between 200 and 400 billion stars, but it's moving at a quarter of the speed of light. This is incredibly fast. And scientists look at this and say, "Guys, there's not enough energy in the entire universe to accelerate these galaxies to the speeds they are. It's too much energy. They can't come up with it." Well, the thing is, so that's why they come up with the idea of dark energy. They also come up with the idea that space is expanding, which is basically changing the laws of science, which I don't think we should do either. So they're trying to either change the facts or the laws because it doesn't make their theory correct. I think yes, sir, sorry.
Yeah, so at this juncture, we're talking about the galaxy moving.
Yes.
So the Voyager 1 and Voyager 2, 2 was launched first and then 1 was launched second. However, the distance where they are now, Voyager 1 is farther out than Voyager 2.
Sure.
And Voyager 2 started sending garbled signals back to Earth. And then they figured it out. And then Voyager 2 caught up with the edge of the heliosphere and started doing the same behavior until they fixed that.
Okay.
So they're quite a distance separated from each other and able to give us enough information to determine that there are some kinds of, I don't know what to call them, I can't remember, like tsunami waves.
Maybe some sort of electromagnetic pulse or gravitational wave, something like that. Could be.
So as the galaxy is moving, maybe some of this energy is causing that?
That is possible. I will say that, when you're talking about satellites here, they're still really within our solar system, or very close to our solar system. Whereas really, there are, 2 or 400 billion solar systems just inside of our one galaxy, which, then I said there are trillions of other galaxies. So we're really more thinking of the actual galaxy itself moving, but that could be why it's causing that. I'm not really sure why the Voyager lost its signal, okay? But anyway, so I don't really know the answer to your question. So I always want to try to give the right answers. I don't always answer anything. So, but anyway, but the point is when we get back to the topic here, so our Milky Way galaxy with our 2 to 400 billion suns is traveling at almost a quarter of the speed of light. And so there's just not enough energy to accelerate to that level. So the thing is that what my hypothesis is that these galaxies accelerate, the white hole accelerated before it accumulated as matter. The matter that it made while it was accelerating, it left behind. And I think probably it's best to show it. Really, I'm kind of jumping a little bit out of order, but it would be this first section of the first stage of a spiral galaxy. As this white hole continues accelerating, the gas that it's making has a slower speed, and so it leaves the gas behind. Okay, the white hole keeps speeding up because it's accelerating. It speeds. You can imagine a race car, like a drag race car, leaving its exhaust behind. Okay, it keeps going faster, but the gas doesn't go faster, so the gas gets left behind. Because of that, the white hole never accumulates any mass until it reaches its terminal velocity. And that way, it's able to be accelerated. Because when a white hole has almost zero mass. So while you couldn't accelerate a huge galaxy to a quarter of the speed of light, something that has almost no mass doesn't really take very much energy to be accelerated at the speed of light. And so that's my theory as to how we were able to achieve these high speeds, that the galaxy accumulated after it was going fast. When it was speeding up, it just left all its matter behind, and it just had no mass, almost no mass, until it reached its terminal velocity. But that's getting a little bit ahead of us. But anyway, so the point is that while the white hole is accelerating, it leaves its gas behind, and only the white hole accelerates and the gas does not. Okay? So that's kind of my theory about how that, or my hypothesis as to how we have arrived at having high mass, high speed galaxies. Okay? Now, what they also notice, and I think this is a corroborating fact, the James Webb Space Telescope can now see much further. And let me just explain to you how they know how old galaxies are and things like that. When the James Webb Space Telescope looks out in the distance, if it's looking at something that's 13 billion light years away, okay, it's actually seeing it when that galaxy was only 700 million light years old. Okay, so we're seeing it very close to the beginning of the universe when it's very young. And so when the James Webb Space Telescope looks into the greatest distance, it sees no spiral galaxies, not any of them. It sees lenticular galaxies and elliptical galaxies. And I'll tell you why in my theory, why I believe they develop much more quickly and more rapidly, whereas the spiral galaxies, according to my hypothesis, don't develop until after they've reached their maximum speed because they've left all that matter behind. And by the way, they do out there find trails, while almost all matter is contained within galaxies, not all of them. They find lines of stars out in the middle of space that they can't explain. Well, I think that these trails that got left behind by the spiral galaxies that have made the hydrogen and then left it behind. And then it's those that are those lines that they then find out in space that they can't really explain. Okay, so in the beginning, there are no early spiral galaxies. And again, I think that's a clue as to why this theory is correct, because according to my theory, a spiral galaxy shouldn't have started to accumulate until it's already reached its maximum speed, maybe after 1 billion years or so. But oddly, what they do find early on is they don't find any spiral galaxies. They find a lot of cigar-shaped galaxies. They look like a loaf of French bread. It's a big line of stars and gas, and it's a straight line, and they can't figure out what that is. Well, according to my theory, that's basically stage 2 here, where you have a very large line of stars And it's only later, after it develops enough mass, the mass will make the gravity, and the gravity will make the arms rotate and spin. And that's called centrifugal force. Okay, so basically the lack of turbulence in these spiral galaxies, that's how the gas gets pushed really far away and left behind. Okay. So we also notice a few other things about spiral galaxies that are unique. They also notice that more mature spiral galaxies, these would be the ones that are closer to us. So if a galaxy's, maybe like the Andromeda galaxy, just a few hundred million light years away or something like that, it's more mature. It's almost as old as everything. It's almost as old as us. When they find those older galaxies, they twist faster. The arms are spinning faster. Well, my theory is the reason that is gravity is making that spin happen. More time allows gravity to act more because gravity acts in its time. And so, the longer the gravity is able to act on this, that will make it spin more. It'll make it spin more because it's had more time to do so. They also find that larger spiral galaxies rotate or spin faster than smaller ones do. And again, it's just a function of gravity. If there's more mass in the galaxy, there's more gravity. More gravity, there's more spin, and more twisting in the spiral arms. And so, hopefully my theory explains that as well. By the way, that's the thing, is there are all these really strange phenomena and strange observations that I can't figure out. To me, I've been working on this theory for almost 25 years now, and I'm thinking out and figuring out how all these things come together and why they work the way they do. So, anyway, and now I'd like to talk to you about it because galaxies don't, about size of galaxies, because galaxies don't just vary in terms of their shapes, being the spirals, lenticulars, like ellipticals, you see the pictures here, but they also vary tremendously in terms of size. And when we look around our local galaxies, so we have the Andromeda galaxy and those spiral galaxies, we have 3 big galaxies, we have 47 little galaxies. And so it almost makes you think that around the rest of the universe, maybe small galaxies are much more common than large galaxies. They certainly are in our local area. And the thing about it is that the Big Bang Theory, with the idea that galaxies are coming together from an outside source, have a very difficult time explaining why small galaxies exist at all, because there's not enough mass in these galaxies to accumulate the matter. But for the white hole hypothesis, it's not that the matter is accumulating from outside, it's being made inside. So basically, a dwarf galaxy is just made by a small white hole, or smaller white holes, depending on the shape. Yes, sir.
Good question. The 3 large galaxies, Andromeda, then is
Something lost. Triangle. I can't remember the name. It begins. I can't remember the name of the third
Is
large
Milky
galaxy.
Way one?
No, the Milky Way is one. There's the Andromeda, and then it's Trialium or something like that. It's try something. I can't remember the name of the third. But there are 3 large spiral galaxies in our group, and they're all moving at roughly the same speed, about a quarter of the speed of light. And so we'll talk more about the potential collision of Andromeda, because Andromeda will collide with our galaxy in the future. People always think that's really interesting. So we'll talk about what I expect to happen there a little bit later in the show. But anyway, so the point is, we see all these dwarf galaxies, and I believe that they're just coming from smaller white holes. And again, it's similar to the other types of galaxies. When they see dwarf lenticular galaxies, just made by 2 white holes. A dwarf elliptical galaxy made by 3 white holes. And now we come to the unusual thing, and that is that astronomers, they find no dwarf spiral galaxies. They don't see them. What they do see, though, are these things like the Magellanic Cloud galaxies. They see these galaxies that are a straight line. Now, have any of you all been to the southern before? Okay, no. You've been to the southern hemisphere. Well, if you look up in the sky, did you see the Magellanic Clouds? That's how you know what I'm talking about then. But you can see up there are other galaxies that are very close to it, of them. And they're small, but they're there. The thing is that when we look at these 2 galaxies, there's, first of all, they call it the Large Magellanic Cloud. Now, when we look at the Large Magellanic Cloud, it looks really round, but that's because we're looking at the end of it. It's like looking at the end of a pencil or the end of a cigar, because we're looking at the end. It seems to be a circle for us, but it's very deep. Okay, it's a cigar shape. Now, when you look at the nearby Small Magellan Cloud, that looks like a cigar, except when it gets close to the Large Magellan Cloud, and then it curves, and so it looks really more like a banana. Okay? And the thing is that end near the Large Magellan Cloud, it curves towards it. I think that's just gravity. The Large Magellan Cloud has more mass than the Small Magellan Cloud, so it pulls the end towards it, and so it curves like a banana. And so, in my estimation and my hypothesis is the reason you don't see any dwarf spiral galaxies is because they're really all the cloud galaxies. And what happened there is that the hydrogen is just pushed too far away, and there's not enough central mass, or not enough gravity to actually cause those arms to twist. So it just looks like a straight line, like a pencil or a cigar. Okay, and so that's how the theory explains that. But I'm glad somebody's actually seen those. Then, Drake. I actually plan to go to Peru in November, because that's a different matter. I've actually got a theory on how the Indians were able to build their large monolithic walls, but that's a different matter. But anyway, that's the purpose of that trip. But anyway, so we understand that. So size matters in terms of small white hole, or small group of white holes make small galaxies. Larger white holes make large galaxies. So now we'll talk about what the astrophysicists call, or the Big Bang theorists call, the galaxy rotation problem. And here's where they have to come up with dark matter. And that is, it's a problem for Big Bang theorists and not for the rest of it, because it tends to disprove the Big Bang theory. And they don't want their theory disproved, so they come up with dark matter instead. And that is that when they look out there, there's not enough matter to produce the gravity that's needed. So whenever they look at rotating galaxies, and so these are not the ellipticals, but the spirals and the lenticulars, the flat rotating galaxies, when they measure they measure all the mass of in the galaxies, so they know how much gravity is there, and then they look at the outer stars, and they measure the speed of those outer stars. Every time the stars are moving too fast to be pulled towards the center, they always look like they're moving away. I like to imagine this as if you're on a merry-go-round, and the merry-go-round is spinning, and an object, if the merry-go-round is spinning really fast, an object sitting out on the edge of the merry-go-round is going to fly away. And that's what it looks like. But they don't want that to be the result, because they think the galaxies are coming together, so they call that the galaxy rotation problem. And that's why they come up with the idea, or the concept of dark matter, because they need the extra gravity, so they invent it. My problem with that is, and the problem with the whole dark matter, the galaxy rotation problem, in my opinion, is that the amount of dark matter always varies for them. So when they look at an elliptical galaxy, they say, oh, we don't need any dark matter. There's almost too much matter there, so they don't find any dark matter in elliptical galaxies. Then when they look at the spiral lenticulars, they tend to find a medium amount of dark matter. But when they look at cloud galaxies, and these smaller galaxies, these dwarf galaxies, they'll need maybe 1 million times more dark matter than they have actual matter. That doesn't make any sense to me. If you were to sit there and say, okay, every time we have one piece of matter, we have the same amount of dark matter, well, that might actually prove that there's dark matter. But if you tell me in some places in space where we have matter, we have no dark matter. In other places, we have some matter, we have a medium amount of dark matter. And then in other types of galaxies, we have a minimal amount of matter and a huge amount of dark matter. It's an inconsistent error. And an inconsistent error means to me you're probably just wrong. And so that's why I think that the galaxy rotation problem is only a problem for Big Bang theorists. For me, it tends to prove what I'm saying correct. And again, I like to follow the observations and scientific law to reach the conclusion, rather than letting the theory lead me to change the facts or the scientific law. By the way, sometimes some of these people will say that gravity operates different at long distances to try to make up their. That doesn't make any sense either. So I'm now going to go through the life cycle of a white hole, so you can kind of understand a little bit more how it develops. I know we've kind of touched on this a little bit before, but there are basically 4 stages of it. So there's the first stage where the white hole is accelerating. As I said, it continues to accelerate. Its gas leaves with a slower speed and gets left behind. And so because of that, it never gains any mass. It just continues to accelerate. But now once that white hole has reached its maximum speed, in our case, 1/4 of the speed of light, once it's reached that, all the hydrogen coming out the side now has the same speed that it does. Because they're all traveling through space at the same speed, well, they stay together. What I might kind of a strange analogy, but a good way for you to picture it, is imagine a fire hydrant on an accelerated train with both sides open and it's just throwing water out as fast as it can. As long as that train is accelerating, that water's getting left behind. But when they are all moving at the same speed, well, then it's kind of, we're staying together, and that's what happens here. So what I believe is happening here is with this white hole, when it's reached its maximum speed, it just keeps pushing out, stays together, it forms a line or a cigar shape, okay, because they have the same velocity, so they stay together. But now, as the thing gets bigger and bigger, more mass develops. And as we get more mass, we step to stage number 3 here. Because you've got more mass, you now have gravity. And as gravity starts to exert a force on the the centripetal force on the outer hydrogen, it starts to twist it. And that's when you start seeing these bars begin to twist, okay? And it does continue to make hydrogen, okay? But the stars are now forming in those spirals, but it is now twisting. And then when we reach a mature spiral galaxy, such as our Milky Way or the Andromeda or the other ones near us, when you get to that level here, something strange, a couple strange things happen. First of all, we've now got a much tighter twist than was happening before. But at that point in time, you start to develop a black hole in the middle. So what happens in that black hole? Well, my hypothesis is the white hole continues to make hydrogen. However, the black hole surrounds it and it encapsulates the white hole and it traps all of that hydrogen. The hydrogen never escapes. Because that hydrogen doesn't escape, that black hole is growing. Not so much from the outside, like a lot of science fiction things make you believe, but really more from the inside, and it grows really big. But when that happens, we'll start talking about the bars of stars, and that'll be coming up in just a moment. But when once it traps like that, the stars stop pushing out because they were being pushed out before by the new gas was pushing out the old gas. But once the new gas stops, the old gas no longer has the pressure pushing it out, and instead has a little bit of momentum from where it was moving before, but it doesn't have the extra force. But now the black hole gravity starts pulling it back, and it stalls in place. And that, I think, will lead us to the next section, which is about the rise of central bars in galaxies. So what that is that a galaxy, a mature galaxy, has kind of a bulge in the middle. It has a lot of stars that kind of, packed in the central core, you might call it. And the thing is, we have all these chairs up here. But the thing is that they find that early in the universe, maybe 10 billion years ago, when they look at galaxies, spiral galaxies are only 3.5 billion years old, only 10% of those had these central bars. But then when they wind forward a little bit later, and you're looking at medium-age galaxies, maybe 6 billion years old, when they see those galaxies, 20% of them now have these central bars. Modern galaxies, now 70% of them have these central bars. To have that kind of a progression from 10% to 20% to 70%, there must be something happening. Something must be causing these central bars of stars to form. The white hole hypothesis tells you that it is the black hole has consumed the white hole and has surrounded it and now captures all the hydrogen, and it's that black hole that stops those stars from being pushed out because that gas stops in place, it stays there. It starts forming stars, and that's the end of these bars of stars across the center of spiral galaxies. Okay, by the way, the Big Bang Theory made no explanation for that thing. So, okay, now we're going on to your topic here, the Andromeda Galaxy. People always wonder, oh my gosh, is our Milky Way going to collide with the Andromeda Galaxy? Yes, it is. It is going to happen. But it's not going to happen for 4.5 billion years, so I think those was in his No, but seriously, well, the thing is that when you look at these galaxies, in the spiral arms, first of all, they're flat, and secondly, they're loosely packed. There are not a lot of stars out there. There's a lot of distance. Like, so from our star to the nearest star, that's quite a distance, and so the thing is, there's mostly just empty space between us. So when the Andromeda Galaxy crashes into our spiral, our Milky Way spiral galaxy. When two spirals like that happen, they're probably not going to hit flat on, but they're going to hit on an edge. And when they hit the leading edge, will hit probably somewhere in the spiral arm of the other one. And since the stars are not very dense, they're probably mostly going to pass through them. It's only when you get to the central bulges, where there are a lot more stars, that at that point in time, collisions are going to become much more common. And so, as long as we are not unfortunate enough to be hit by the central bulge of the Andromeda Galaxy, we'll probably be safe and be undisturbed. However, when the black hole of the Andromeda comes through, everything that it comes into contact, it will just consume everything, and everything will basically be pressed flat against it. So, but then after the two galaxies will actually pass through each other and continue to exist. However, their gravity will again slow the momentum, and it'll come back for a second pass, and they'll continue to come back towards each other, probably in perpetuity until eventually they do merge. And at that point, you'll probably end up with a really messed up looking galaxy, which will be what they sometimes find these irregular shaped galaxies around the universe that they can't explain. And that's probably from the collision of two different types of galaxies. So I don't think we need to worry too much about the Andromeda Galaxy colliding with us. So, and now I'm going to talk to you about what they call cosmic background radiation. And this was a really unusual discovery, and a very important discovery, back in 1964, oddly the year of my birth. But anyway, the thing is that when Big Bang theorists said, hey, if there was a Big Bang, there's probably the same energy everywhere in the universe. And some astronomers in Princeton were looking at that, and they were finding that everywhere they looked in empty space, the temperature was always 3.5 to 4 degrees Kelvin. It's just a little bit above absolute zero. So really cold, but not perfectly cold. And so they noticed, though, that everywhere they pointed their telescope in empty space, it was always the same temperature. And so, boy, that was a really unusual thing. At first, they thought they had a defect in their telescopes, in their measuring systems, but that was not the case. They were actually measuring it correctly. And so the thing is that they then began to wonder, and that really became, I would say, the biggest nugget of proof that Big Bang theorists had for their Big Bang theory, and that basically that the universe was just formed by a giant explosion. I don't think that's a correct interpretation of this fact, okay? The fact that everything is the same temperature, what they call thermal radiation, that does say to you that everything came from one place, that originally it must have all somehow been in one place, because otherwise it couldn't all be the same everywhere throughout the universe. But it doesn't mean that there was a Big Bang explosion. My white hole hypothesis says that basically everything started from a point. I don't want to get too much into the theory because I don't want to glaze your eyes or have people fall asleep or anything. But basically that the one point vibrated and then it ended up making the first dimension, which when that got full, cracked and made the second dimension, which continued to expand until that got full, and then that made our third dimension. But the point is that my theory does also presume that everything did come originally from a single point. But the Big Bang theory would tell you that there was a single point of infinite density, and that made everything. But I think there are different interpretations to that fact. So anyway, we now are at this time when people look out there and they see a lot of things that seem to refute the Big Bang. Then we now have to wonder, is the Big Bang theory completely refuted? A lot of astronomers still kind of cling on to come up with different things. But I think that it is clearly refuted. And again, it's because of the inconsistent errors of both dark energy and dark matter. Because when you look at dark energy, they would say that our Milky Way has a huge amount of dark energy because we're traveling at a quarter of the speed of light with 200 billion, 400 billion stars. But then they say an elliptical galaxy, not moving at all, just staying in the same place that it always was, has no dark energy. Well, how would that, doesn't that seem inconsistent to everybody that one area of space would have a huge amount, so much more dark energy than the whole universe, and another place would have none? Doesn't seem very right. So anyway, that's basically my theory in a nutshell. I will kind of digress to two other kind of related topics, one of which is an interesting and true story, and the other one is maybe more a matter of theology. And since it's Sunday, I will say that while the Big Bang theory would like you to believe that everything in the universe is an accident and therefore there is no God, there is there's no creator or anything like that, because it's just a huge accident. My theory is, I think you see, there is some sort of coordinated system that my theory, I believe, lends itself to what they would call intelligent design. And so, for people who are interested in religious studies, I believe that my theory does reopen the door to divinity and the possibility of God having created everything out there. And so that's the one portion, that's the Sunday portion. And then lastly, this is more of an entertaining but true story, and so we'll digress into my personal situation. Hopefully all the people who watch the video, if they watch it on YouTube, will turn it off by this time, so I won't be thoroughly embarrassed. But my theory actually began in the year 2000. I had a girlfriend over in Thailand, went over to see her. I'd seen her the year before, it was fantastic. Went over there, found out that not only was I not her only boyfriend, I wasn't even number 1, 2, or 3. So this having happened to me, I think a few of you received my emails during the process. Like, oh my God, Carl has really lost his marbles. Because I then went on a period of 8 days without eating. I think you remember receiving these, right, Mary? I didn't eat any solid food for 8 days. I also, because I looked around and saw these monks and the way that they walked everywhere and didn't take any transportation, I just walked everywhere. So I climbed a lot of mountains to a lot of temples. I climbed a lot of waterfalls. I drank a lot of water, but I didn't eat any solid food for 8 days. And then I also, because I noticed none of these monks spoke any English, I didn't speak any English for 8 days either. Unfortunately, I didn't really speak Thai very well either, so I didn't really speak very much for 8 days. And so it happened that on day 8, I was sitting in a mountain waterfall, and I think at this point, I was completely wiped out. And I think that's the point where somebody becomes almost like an empty vessel. I was crushed. I had no energy. I was delirious. I couldn't do anything. And that time in my life of being an empty vessel, I was just sitting there, and I don't know if you want to call it an epiphany, God sending me how it happened, but suddenly, sitting in that waterfall, I suddenly had the realization for how all the universe was formed and all the galaxies. And even though I hadn't taken math science class in 20 years, I then had to kind of speed up my mathematical and science studies to figure things out. But the point is that that's actually how this theory originated, but that was, about 25 years ago, and so I've been working on it for a long time. So anyway, you're the first public presentation. I hope you've enjoyed it. And if any of you held your questions, feel free to ask them now. No questions? Yeah, go ahead with your question.
Okay, so now that I just learned that the Milky Way is its own distinct black hole.
Well, it has a black hole in it, yes, sir.
In it?
Yes, in the center. And every spiral galaxy, and really every galaxy will have every mature galaxy will have a black hole. Now, like these dwarf spirals or these clouds, they will not have a black hole. But our Milky Way does have a large central black hole.
Okay, I'll hold some other questions.
No, feel free. You're the only one asking them. Please ask. Let's hear them.
Well, okay, so then my next question was, because you did mention that the next galaxy over Andromeda has a black hole.
It does, black hole as well.
Okay, so could it be that all of these galaxies dwell within the main big black hole?
Oh, I wouldn't have thought so, but I mean, I don't have a monopoly on correct answers. But in my thinking on black hole, I know you see this stuff. You see all this stuff in these scientific theories. If you travel in a black hole, you travel back into time and all this stuff. I personally think really all that a black hole is that matter has collapsed down to neutrons, and it is just a complete pack, like a black ball of neutrons that you couldn't pack anything tighter, and that's why it has extreme gravity. I think that anything that approaches a black hole, it's just almost sucked flat to it. All of its matter is just collapsed into neutrons. So basically, your body, if you went up a black hole, would be just a mere speck, and everything would just collapse down and then just stuck to the surface of the black hole and be completely obliterated.
Okay, so then to take this into, let's say, a rebuttal or an argument, so your white hole theory is with all the hydrogen gas accumulating, eventually becoming a star?
Well, hydrogen gas does accumulate into stars, and it depends on how tightly that hydrogen is packed as to how quickly it forms a star. It's got to have a certain density before it will actually get to be a star and get to have fusion occurring. Fusion occurs when there's enough gravity that makes enough pressure that you then have enough heat to create fusion in the center of the star.
So that's where my question came from.
Sure.
Because we have a star and we call it the sun.
Sure. Yeah, we have a second generation star, yellow star. There are impurities in our star, and that's also why we have planets, because these impurities are things like hydrogen, are carbon, oxygen, iron. These are impurities. Now, I believe that the reason these solar systems form is that because of the way that the sun is spinning, they throw some of those heavier bits out, and so that's why you see the planets tend to have a lot more impurities than the sun. The sun is almost all hydrogen, but not all hydrogen. Okay.
I have a
Good. What's your
question.
question?
When you talked about acceleration, I guess it's the Sunday question. How did the acceleration start?
Well, that's a big question. I would think that what happened, according to my hypothesis, is that the second dimension shattered. I think that there was an initial force on the inside. I think this is actually how they have unified force theory. The nuclear force formed the first dimension by shattering. The electrical force formed our dimension when it shattered. And so basically, I think you have a leftover of that. And the gravitational force is really just the electrical force spread out across our universe. And so it's from that force that it will make things move. And the thing is, a white hole, the equation for acceleration is basically force equals mass times acceleration. So I don't believe the force is very large. I think the force is very small, okay? And the thing is, though, is that a white hole, because it's only one atom thin, or one atom thick, it has almost no mass. And so that's the only way that it can accelerate, is because the force isn't very big, but the mass is even smaller. And so that's how it's able to accelerate. And at least that's my theory. But, you could ask 100 scientists that question, and you get 100 different answers. So, but that's what I believe is happening. I mean, I do believe that Newton's laws of science are correct. I believe that force equals mass times acceleration. I don't think you have all these other crazy theories that people want to talk about spatial expansion and changing the force. They come up with all kinds of crazy ideas to make their theories seem right. But I believe that this force is extremely small. I believe that it is the electrical force spread out across a large distance, which ended up being the gravitational force. But I think that small force was able to accelerate a white hole if the white hole was really small. If the white hole was bigger, like an elliptical galaxy, it didn't move it at all. And that's why those are all found in great walls. Yeah, Gary, what's your Please don't go back to the year 2000.
No,
Embarrassing.
no.
I'm just teasing you. I'm
That's
joking.
for later.
That's
for
for
later.
tonight.
Is there a finite number of white holes, or a white
Oh,
holes continuously?
I don't believe so. I believe, oh no, I think that they were all made with the second dimension shattered, but I think the second dimension is probably infinite. So there could be an infinite number of
So we may not know the number of them,
we may not.
but they're not new ones being made.
I don't believe there are any being made, but I do believe that eventually, but this is an extreme amount of time in the future, I believe the third dimension will also be completely filled, but this is gazillions of years in the future. And I think when that happens, when the third dimension is filled, it will also shatter. It will create another force, and it will create a fourth dimension. But you're talking so far in the future that's beyond theory. Hey, what you got?
I have a silly question.
Sure.
But when we're looking at when the white hole comes into being and it kicks off the hydrogen, is there any evidence or any concept of how oxygen plays a role?
Oh, okay.
Because we're really talking about planetary life, and if Earth is the only one that has water, and yet we're seeking through NASA to see if there's water that might exist on Mars. I mean, how does that play into your
Here, I can
concept?
explain it to you. So when you first of all start with a first generation star, just pure hydrogen, okay? It's just making hydrogen and helium, okay? Eventually, that gets so compacted that you actually go supernova. And it's at that supernova event that at that point, additional elements are created. And so it's when your first generation stars go supernova that now you're making oxygen, you're making carbon, you're making, all kinds of other things, zinc, iron, whatever it is, uranium, all kinds of things are made when a first generation star, a supernova, it basically has so much gravity and it compresses those other heliums and hydrogens into the more complex elements. And so you really would probably not find any oxygen or carbon nor any life near a first generation star because it doesn't have those impurities. You're a whole lot more likely to find that around second generation stars like our yellow sun, or if you were to go to a red star, a third generation star. Hey, what you got? Go for it. Give me another. No, don't make your lattice. Keep going.
You mentioned the fourth dimension.
Okay, that's all theoretical, but sure.
Okay, is not the fourth dimension the speed of light?
I wouldn't have thought so. Although I think there are actually other dimensions inside, smaller dimensions inside our first dimension. If we're going to find other dimensions, they're actually going to be smaller and they're going to be inside, but we would probably never be able to observe them. We can't even just observe an atom except indirectly. So you're never, I don't think you'll ever be able to see inside an atom. But I think other dimensions are inside. But a larger dimension, I think there will just be more larger physical dimensions eventually. But like I said, you're talking gazillions years.
So if this hypothesis aligns with your theory about the white hole and the speed of it, once it reaches a particular point, the hydrogen atoms being pushed out travel at the same speed.
Okay, yeah, basically you're speaking here at the second stage of a spiral galaxy. Yes, when the white hole, when it reaches, you've got the force equals mass times acceleration. When it's accelerated to its limit, and it's not going to go any faster, when it stops going faster, now the gas that it's making has the same velocity, has the same speed. They're not traveling together through the universe. Whereas before, the white hole was accelerating, the hydrogen gas has a lower speed until it leaves its hydrogen behind. It's kind of like a bad parent.
That's square one.
Sorry, couldn't pass that one. Okay. All right, with that terrible joke, are we done? Okay, David, else have any other questions?
I just have a follow-up.
Feel free.
What do you expect to be the next step for your theory?
Oh, well,
Process?
here's the thing, Nancy. I've come to realize that no astrophysicist will ever speak to me. They're not going to talk to me. I'm going podcast. I intend to try to go to places like Joe Rogan and stuff like that and let people hear it, because I believe that my theory makes sense to normal people. I think people say, oh, this makes a whole lot more sense than their crazy ideas of dark matter, dark energy, space expanding, or whatever crazy stuff they come up with. And so I also believe that eventually, I think that this theory will be proven correct, and I think that it will be correct, but I may not be the person getting credit for it. I believe that somebody with probably more appropriate letters behind their name will
But
probably.
I don't think you're doing it for credit. I think
No,
you're
I'm
doing
not.
it, yeah.
I just want people to realize what's going on. I think people should realize that this Big Bang theory, we're just chasing down the wrong rabbit hole. You're going to dead end holes if there's nothing there. Okay? And I think that's leading a lot of people wrong in life. Go for it, Mike.
So the Earth isn't flat?
No.
No, well, my real question is, you said creating hydrogen. Have you thought about that a little bit?
Okay, here's the situation. I believe that that a white hole has the ability to duplicate or replicate itself. I think that it got this when originally we started with just a single atom. I think that it vibrated or it moved. And if it then took up two places in space, it actually became two things. And I think this is the one prevailing trait that carry across different dimensions, is the ability to duplicate itself. And so I believe that a white hole is really basically a sheet of almost like single atoms that they duplicate each other. And they're almost kind of vibrating, and that's why it's pushing out hydrogen atom. It's basically making hydrogen, there's no place to put it, because it's too thin. And so it duplicates itself, but doesn't have any place to put it, so it pushes out.
I have a part two.
Okay, perfect.
Would you agree that energy is neither created nor destroyed? And if so, what was before the hydrogen?
You know,
And that might be a little off.
I think that we are creating matter, and really in creating matter, maybe we're also creating energy with the E equals mc squared. You know, I'm not sure on that one. I'm kind of working on that one, But that's a topic, I considered putting that in this, but I haven't really finished that part of my theory, I've been thinking about that.
Yeah.
So that's still under consideration and under theoretical investigations, everything.
I'm sorry, I didn't want to challenge you with
No,
anything,
that's all right.
I just want to think
That's all right.
about it.
Hey, I don't mind the challenge, I mean, I don't mind.
And it wasn't a challenge.
It's no
It's just
problem.
about
Not bothering me.
that's all.
I don't mind, I don't mind. Hey, I'm wrong at least once a day or twice on Sunday.
Yeah, me too.
You mentioned about the, I heard about the universe expanding, and then they quote proved it by the way the light is shifting and so forth, is that?
You know, actually, I would have to say that that's actually probably the opposite of what's been true. There's an astronomer, and I think he's one of the smartest ones out there, Kilmarnock. And what he says is that he looks at it, and he says, oh, you scientists say that space is expanding, stretching, and that's how galaxies are traveling so fast. But he points out, he says, when I measure, the light itself does not stretch. And he says, because the light is not stretching, space is not stretching. And I think that guy's right. I've seen him be right on a few other things too. But so I don't think that's what's being proven at all. I think that's a great deal of controversy in astrophysics. And I have to be with Eric Garner, who says that space is not expanding and light is not stretching. And that we just live in basically a new universe. You know, the scientific laws that we see really are the laws. And the universe really does follow them. And it's not a matter of just kind of making up whatever law you want to make your theory seem true. So, but that is an area of controversy. There are definitely different astrophysicists on different sides on that one, but I'm going with the guy who doesn't think space is stretching. You know what you got?
Yeah, so what do you think would be the, like, let's just say that your fear, your hypothesis, let's say 100 years in the future was proven correct. What would be the implications for this theory, your hypothesis being turned into theory? Like, where would civilization go with this? And
Well,
what are your
here's where I think
the
that's
answer?
right. You know, see, one of the biggest things that eluded Einstein for long is how to unify a field. How do you relate the different forces together? Okay, that's actually another aspect of what I'm working on. I was thinking about that's kind of related to Glenn's question, but I also haven't answered that question at this point in time. But I believe that what is happening is that the original nuclear force was limited to a nuclear atom, but then we find out that force is extremely strong, has a very limited range, only the size of an atom. It doesn't mean the nuclear force doesn't mean anything to you or me. But then when you step up to the second dimension, okay, you then create the electrical force. The electrical force has more of a range. I mean, a shock could go from medium, lightning could go from the skies to the earth. It can have a larger range. It's stronger at a shorter range. And so the thing is with forces is that they tend to have when they have shorter range, they're stronger, but the electrical force has a medium power, but has a medium range. And then gravity, being the next one, has a very long range, perhaps across the entire universe, but it's a much smaller force. It's much weak. Gravity is much weaker than the electrical force. The nuclear force is stronger, and even stronger than the nuclear force. The nuclear force breaks down into the weak nuclear force and the strong nuclear force. The weak nuclear force has a longer range. Strong nuclear force is actually inside of the atom. But I don't think I quite answered your question. Your question was, where does this lead us to? And I guess I got to
where do you want it to go?
Yeah, I got it. I had to go around the tree to get there. But the way it is that if it is that we are able to understand forces much better like that, and we're able to now understand, we now understand how the nuclear force, electric force, and gravitational force are all related. If we're able to understand that, I believe that is how we're going to unlock things like fusion and unlimited power. You're not going to need hydrocarbons anymore. There's not. I got nuclear power. I mean, I got fusion. And I think that if that is correct, I think in 100 years, I think when they understand how forces work together, I think that's the long range, is that you will have unlimited power and you'll all be free. And it costs nothing, and you won't need to be burning gas or old dinosaurs or old ferns or whatever.
So, secondly, do you think that, okay, we know we're in this universe, and so there's been a lot of talk about, with lots of people, you know, is there another universe where other people, beings, or something you can communicate with through radio waves is something else out there? Like when we're going out there and our radio waves reach to here or there or wherever, do you have any sense from your studies, like, you know, what are we looking for? Like as a people,
You actually
people.
have two questions in there, so I'm gonna answer them one at a time. First of all, there are people who sit there and say, oh, they're parallel universes.
Yeah.
I don't see any evidence of that. Where's the evidence? I mean, I'm kind of a guy that's like, I see it, I believe it, you know, and I gotta see something. Just a complete speculation, oh, there's another universe, there's one. It could be, heck, it could even be within us, because the thing is that when you look at an atom, I mean, the nucleus and the electron take up probably 1/1,000,000th of the space. It's mostly empty space. You're actually mostly empty space, and so am I. I mean, it's kind of odd, but I don't believe there's a parallel universe or parallel universes or all that Spider-Man multiverses or Doctor Strange or whatever crap it is. I believe that's all speculation or fantasy until I actually see something to believe it. However, you then mentioned space aliens, and that's a different story. Look, when we look out there, you got 200 or 400 billion stars out there, and just in our galaxy. How could there not be aliens out there? There are too many planets for there not to be aliens. God, there could be 1 trillion planets just in our galaxy. I mean, you know, you don't have to have much of a percentage of chance for them to be aliens. Now the question is, will they ever get here? That's the problem. Everything's so far away. Things are really much further away than you think they are. You know, I mean, I guess the nearest habitable planet, who knows how far that is, but it could be 1,000 light years away and never get there in your lifetime. So, you know, I don't know if we're going to see space aliens because they might just be too far away.
Well, you know, we're the only planet that can, you know, with intelligent design is surviving because we have an equal, you know, proportion of sun, water, climate. We can't live on Mars because it isn't habitable. It's not going to sustain human life. But you know, somewhere out there could be another sun like ours, and the equal.
Oh, they find
them.
And by the way, they call these other places super Earth, and they do find them. They find other planets that also have hydrogen and oxygen, and they tend to have to find them. They find them if they're within a certain range of their star, that they're not too hot, that they're roasting, and they're not too cold, that they don't have any
Right,
energy.
and there's
But there are plenty of them. They already find them.
And I don't know the exact name of this, but there was this person who, you know, a scientist who wrote a book in the early 1900s about the center of the Earth, you know, and believed that in the center of the Earth where you have the core.
Was this Jules Verne, like Journey?
Yeah, and it was like a lot of theories and like, you know, drawings.
There could be something.
What is in the center?
It's possible.
But then they said you could get there, like you could get through. I don't know if it was fiction or if it was.
It might be a little science fiction, but there could be life underneath us. I mean, it's probably warm enough down there. It just doesn't have any sun, but you know, I don't know. I mean, I don't know. It's possible.
Falling through the, you know.
I mean, nobody's been there yet, but it certainly could happen. What's your question?
Well, I think
I was reading and thought, wow, that's an interesting thing, you know.
May-
Thought of.
if I would rephrase my statement into a question, it would be like, so do you think in this parallel universe question and the God question, like Jesus raising Lazarus from the dead, so in the parallel universe, he's still somewhere alive and comes back?
I guess so, but I think you're now into like some Doctor Strange multiverse. I don't know. You really can't jump into multiverses or parallel universes.
Sure.
But anyway, but basically, what I see here, my whole hypothesis, it's based upon the evidence that I see. It's based upon the facts and the observations, and then I just apply scientific law. But I do think that instead of it being just some complete random, unintelligible accident that the Big Bang theorists have to believe, I believe there is a method to the madness, or there's a plan to it, and that certainly bodes well for the idea of intelligent design.
It does seem quite orderly.
It is orderly, and that's the whole point. I mean, they follow a very similar pattern. When you look out there among all these trillions of galaxies, they all are very consistent. I mean, these spiral galaxies, they're all flat, They all have a central bulge, they're all very organized, they all have extra gas and dust to make new stars. When you look at the lenticulars, and they're kind of a medium, and the ellipticals are all what they call red and dead, they're all burned out. But, like I say, it does seem like a very orderly plan to me, and I just see the pattern in it. I think a lot of these people, it's like they're looking at a painting, but they're looking at the back of the painting, they can't understand it, they need to walk around to the front and see it.
Have you ever tried to contact, any of the, or current or former astronauts who have visited space to see, like, I want to ask you, like, what are your impressions of what I'm thinking about, and see what they think?
No, I never really thought about that.
That would be interesting.
I was really more trying to contact, astrophysicists and cosmologists and focusing on this area for scientific study.
Well, my cousin is an astrophysicist, and he
Great, give
he
my book.
put up a space
I'll give you an
station
extra
up there.
one.
He's retired, but I can give you his name and.
Sure, I'd be glad to
I'm
send
gonna
it.
share your book with him.
Please do.
See if
Please
you can get in
do. I always
contact.
like to hear other opinions.
He loves to discuss it. I mean,
Like I say,
he knows more than what I could explain.
no one has every correct answer, and I'm not different from that. Everybody's got.
Well, he
There's
loves
always
all
to
the
find
theories.
something that has something.
Hey Carl, so this can be an elliptical universe?
That could be an elliptical, but if you were, it always depends on your viewpoint. See, a spiral will look round if you're looking at it from top
Right.
down, but if you're looking at it from the edge, it just looks like flat. And when you look at a galaxy, flat galaxy, either a spiral or a lenticular, you can't really tell the difference if you're looking at the edge.
That's what I'm saying, if you talk to an astronaut, saying what did they see from space, in space, that would be interesting.
I guess
They
we
only
do
went,
that.
Oh,
they
sure.
only went so far.
Yeah, I mean-
Or like the people who are on Hubble, that's what my cousin did.
Well, no, you answered it, one was flat.
Oh,
Because in-
yes,
so
the
the-
spiral galaxy is flat. You're looking at the
So-
top view.
The
This is
arms,
sort of an edge view, kind of a medium view.
so the arms are like debris?
Well, the arms are really more of the hydrogen gas that got pushed out. And you'll notice out those arms are a lot of blue stars.
So it's like.
And those are pure hydrogen stars, they're first generation stars. As you get closer, you'll see a lot more yellow stars closer to the center. And that's because they've gone through a different generation. It had some explosions, supernovas, and it did have the carbons and the oxygens and what other impurities. That's what it is.
Looking at that picture, you see it rotating left or right?
This
Clockwise or
galaxy
counterclockwise?
is going counterclockwise.
Right.
I believe that the center is going counterclockwise.
So the debris is slowing down? Oh, no, not necessarily.
Well, I think that the center is turning this way.
Yeah.
And so that's where you get rotation. Okay?
I got you.
All right. So if there are no other questions, I hope you all enjoyed yourselves. Very nice. This is my debut, so. Hey, thanks for coming. Okay, I was a little worried nobody was gonna show up. I'm sitting around here, I'm like, Alvaro, is that for 2